Welcome to all of you in Sankalp Education Pratham classes. I am Sachin Patel, delivered lecture series on rotational dynamics. Right now we are going with point mass undergoing vertical circular motion under gravity. We know that the vertical circular motion is controlled vertical circular motion and vertical circular motion under gravity. We are now studied with the concept of point mass undergoing vertical circular motion under gravity, inside which case 1 is mass tied to the string. It is thoroughly or clearly discussed in previous lecture. Right now we are going with the case 2, mass tied to a rod. Mass tied to a rod, it is practically equal to that of the mass tied to the string, but there will be a basic difference in between that two is the rod and string. Rod and string having basic difference, as follow. Because rod and string is flexible, but rod is not flexible, and therefore in rod and string we will get the basic difference as in a vertical circular motion as that of string is string needs some tension at all the points in V.C.M, in vertical circular motion, and including uppermost point, but this thus the certain minimum speed, this certain minimum speed require at every point for maintaining tension in the string, and if you require to maintain this tension in the string, you will require the minimum speed, and that minimum speed also required at the uppermost point also, and inside the rod, in case of rod, there is no requirement to maintain tension in it. Thus in case of rod, at uppermost point, velocity or speed may be zero, is also possible. That means we can take the consideration of V at the topmost point. We know that in a previous lecture we studied the mass tied to the string. At that time you will know that in a vertical circular motion, we have three concepts. One is the center is here. This is the lowermost point, it is nothing but a point B. It is uppermost point, it is point A. It is a horizontal point, that means point C, and D are the points here. And from these 3 points or 3 concentration, we have to follow the concentration. Here VA be the velocity, here VB be the velocity, and here we will get the VC or VD be the velocities are there, and we will take the consideration of at the uppermost point in consideration of rod. When we take the rod as a radius, there will be no requirement of the velocity at the uppermost point, and therefore VA is equal to 0 is possible. That means it is very easily tied to a point mass to the rod, and we can put it in a horizontal, put it at the uppermost point without losing the radius of the vertical circular motion, and therefore VA is equal to 0 also possible inside the case of that mass tied to the rod. And therefore you will get the minimum speed at the lowermost point. That means you have to get the lowermost point is a B point. It is a lowermost point, and it is a uppermost point. At the uppermost point, it is possible to maintain the velocity or speed at the point A is equal to 0. And we know about the consideration of velocity, consideration of equation VB square minus VA square is equal to 4RG is here, and VA is equal to 0. Putting inside this equation, you will get the VB square is equal to 4RG, and taking the root on both sides, you will get the VB is equal to square root of 4RG, and it is equal to 2 into square root of RG. This is the minimum speed at the lowermost point. It is a lowermost point speed, lowermost point speed. And we will get the VB is equal to minimum velocity at the lowermost point is 2 into square root of RG, as well as you can perform the considerations related to that one, and you will get the minimum velocity, minimum velocity or speed velocity at rod becomes horizontal is, we have to take the V minimum is there, and at horizontal position it will have the value square root of 2RG. In a previous case, we know that at the point C and D, you will get the velocity at that horizontal position is square root of 3RG, and right now in this condition we will get the V minimum is equal to square root of 2RG, as well as we will get the consideration of tension at lowermost point, that means B, minus tension at uppermost point, that means A, is equal to 6 mg, and it is also implies the consideration of T lowermost minus T uppermost is equal to 6 mg. Those are the considerations related to mass tied to the rod, and it is a vertical circular motion under gravity. Right now we are going with the next point related to our vertical circular motion is as follows. It is a sphere of death. Sphere of death means mrityu hole. Inside this we have to consider the two-wheeler. It is a famous or popular show inside the circus. It is a popular show inside the circus. We have to visualize this circus inside which a two-wheeler rider undergo rounds inside hollow sphere, performing vertical circular motion and having same dynamics as that of point mass tied to string. Point mass tied to string, and therefore it performs the same consideration as that of a string, point mass attached to the string, but inside the point mass tied to the string we consider tension T in string. Here just a small change is that of we use or we consider a normal reaction N at the place of tension. We have to put the normal reaction, and you can perform the same dynamics related to the point mass attached to the string, and you will get the same clearance of a sphere of depth, inside which you will get the consideration of that vertical circular motion, and which performs the vertical circular motion in which mass tied to the string, and inside the mass tied to the string we have to use the tension T in the string, but inside the sphere of depth we have to use the normal reaction which replaces the tension in the string, and sphere of depth which perform the vertical circular motion, like that case number 1 is there. Now we are going with the next point is related to vehicle at the top of convex overbridge. It is once again one example related to the vertical circular motion, inside which we have to consider a convex overbridge as like that of, it is a convex overbridge. This is the convex overbridge, and our vehicle is reaches at the top of that overbridge is here, and we are moving in this way. Our vehicle is reaches at the top of overbridge, and you have to perform a velocity in this forward direction, and we have to reach at the top of that overbridge. Let us consider R be the radius of that overbridge, and R be the radius of that overbridge, and here weight, we know that the weight of a vehicle or any object which is acting in downward direction, and normal reaction is acting in upward direction here, and therefore when vehicle reaches at the top of overbridge, you will get the force acting on the vehicle are two forces, which are nothing but a weight mg and normal reaction force, that is a n. That means you have to put consideration here. Let r be the radius of overbridge, and when a vehicle at top of bridge is a part of vertical circular motion, and forces acting on vehicle are given as, first is weight mg in a downward direction, and second normal reaction force, that is n, in upward direction, and a resultant of those two forces must provide the centripetal force. Resultant of these two forces provides provides centripetal force vertically downward if v be the velocity at that point, then you will get the consideration of mg minus n is equal to mv square divided by r is here. And from this, when v increases, n goes on decreasing. That means normal reaction, which is most important for the maintaining the contact with the overbridge. When we having the larger velocity at that time, the contact of our tire and road is completely lost, and your vehicle not moving in this direction. Vehicle not moving in this direction, it moving in this direction, that means it completely lost the friction or lost the contact with the horizontal overbridge, and you are moving in those direction. Therefore the normal reaction, that is a normal reaction is indication of contact with surface of road, and we know that if v is increases, then n goes on decreasing. What does it mean? At a particular limit, n becomes 0. That means our contact with the road is completely lost, and normal reaction does not work on that vehicle. At that time normal reaction becomes 0 when we are moving in this way, and your contact with that road is completely lost, and therefore it having some limiting value of speed on the overbridge, and therefore it is given as, therefore thus n is equal to 0. It gives upper limit on speed on overbridge. That means when we overcome that limit of speed, at that time your contact related to that road of the bridge is completely lost. At that time normal reaction becomes 0, and we are moving through air like a hero which is performing stunt in the movies, and your vehicle is moved like that one. It is not moving in this way, and therefore normal reaction n is equal to 0. It gives a consideration of n is equal to 0, and therefore mg minus 0 is equal to mv max square, because right now velocity is maximum and r be the radius of that overbridge, and therefore mg is equal to mv max square divided by r, and we have to solve this consideration. We get v max is equal to square root of rg is here, and this is your expression related to maximum velocity when vehicle at the top of convex of overbridge, and you will get the speed limit related to your vehicle when we are moving on the convex overbridge, and which is nothing but v max is equal to square root of rg. That means maximum velocity of vehicle when moves on a convex overbridge. It is also like a speed breaker. when we move on the speed breaker, at that time you will get the maximum speed. Other maximum speed is a speed limit on that moving over the speed breaker. If we are not in a speed limit, at that time our vehicle goes in the air and it moves like that one. It moving in front of that, and it is a touches to the ground by flying inside the air for few seconds or few microseconds are there, and you will get this speed limit related to that maximum velocity. This is related to your vertical circular motion. Inside the vertical circular motion, we have to going with a controlled vertical circular motion and vertical circular motion controlled by gravity. In controlled by gravity, you have to going with the 2 points or 2 cases related to mass tied to the string and mass tied to the rod. Then we are moving with a spear of death, and then vehicle at the top of convex overbridge. And those are the points related to that vertical circular motion. If you like that video, then subscribe my channel and click on the bell icon to get the next notification related to that rotational dynamics lecture series. Thank you.